block, you see it there, and that block weighs 2 kilograms. Red block. So here it is. It's red. And I have 2 strings. It's hanging from a black string here and a black string there. Ignore that red string, that is just a safety. But it's a very thin thread here and here. And they are, as close as we can make them, the same. They come from the same batch. This one has a mass of 2 kilograms, and this string has no mass. This is 2 kilograms. So what will be the tension in the upper string, which is string number 1? This is string number 2. Well, this string must be able to carry this 2 kilograms, so the tension has to be 20 newtons. So you will find here a tension, call it T1, which is about 20 newtons. So it's pulling up on this object. It's also pulling down from the ceiling, by the way. Think about it. It's pulling from the ceiling. The tension is here, 20 newtons. We could put in here one of these scales, and you would see approximately 20 newtons. What is the tension here? Well, the tension here is very close to 0. There's nothing hanging on it, and the string has no weight, so there's no tension there. You can see that. Now, I am going to pull on here. And I'm going to increase the tension on the bottom one until one of the 2 breaks. So this tension goes up and up. And therefore, since this object is not being accelerated, you're going to get a force down now on this object. This tension must increase, right? You see that. If I have a force on this one, so there's a force here, and there is mg, then of course this string must now be mg plus this force. So the tension will go up here, and the tension will go up here. The strings are as identical as they can be. Which of the strings will break first? What do you think? Excuse me? I can't hear you. The one on top. Who is in favor of the one on top? Who says no, the bottom one? Who says they won't break at all? Okay. Let's take a look at it. The one on top. That's the most likely, right? 3, 2, 1, 0. The bottom one broke. My goodness. Newton's second law is at stake. Newton's third law is at stake. The whole world is at stake. Something is not working. I increased tension here. This one didn't break. Is this one stronger, perhaps? No, I don't cheat on you. I'm not a magician. I want to teach you physics. Did we overlook something? You know, I'll give you a second chance. We'll do it again. Let's have another vote. So I'll give you a chance to change your mind. There's nothing wrong in life changing your mind. It's one of the greatest things that you can do. What do you think will happen now? Who is in favor still of the top one? Seeing is believing. You still insist on the top one. Who is now in favor of the bottom one? Ah, many of you got converted, right? Okay. There we go. 3, 2, 1, 0. The top one broke. So some of you were right. Now I'm getting so confused. I can't believe it anymore. First we argued that the top one should break, but it didn't. The bottom one broke. Then we had another vote, and then the top one broke. Is someone pulling our leg? I suggest we do it one more time. I suggest we do it one more time, and whatever is going to happen, that's the winner. If the top one breaks, that's the winner. The bottom one breaks, well, then we have to accept that. But I want you to vote again. I want you to vote again on this decisive measurement, whether the top one will break first or the bottom one. Who is in favor of the top one? Many of you are scared, right? You're not voting anymore. I can tell you're not voting. Who is in favor of the bottom one? Only 10 people are voting. Let's do this in an undemocratic way. You may decide. What's your name? Alisa? Georgia, close enough. You may decide whether the top one or the bottom one will break. Isn't that great? Doesn't it give you a fantastic amount of power? The bottom one. The bottom one. We ready? 3, 2, 1, 0. Bottom one broke. You were right. You will pass this course. Thank you, and see you Wednesday. By the way, think about this. Think about this.